Hi, today I'll present about an area of research in which symbolic reasoning and machine learning are combined, namely the automatic extraction of temporal information from text. So we conducted a literature survey on published temporal information extraction systems that use some form of temporal reasoning. And with temporal reasoning we mean combining small pieces of temporal information to obtain a more complete temporal picture of the text. In this 5-minute talk, I'll not go into detail about the results from the survey, but focus on what types of information can occur in language and the currently most used frameworks for temporal reasoning. In the 15-minute talk, I'll dive more into how temporal reasoning can be integrated into information extraction systems. So I'd like to start with the following example. Antibiotics were started on the 2nd of June and continued for 10 days. In this sentence, there's one event mentioned, the administration of antibiotics. Temporally, an event is generally interpreted as the time interval during which the event took place, as depicted here. Our first temporal cue is a verb tense, indicating that the event started before the document creation time, so in the past. The next cue is an absolute reference to the start time, the 6th of June, referring directly to the calendar timeline. And finally, there's an absolute reference to the duration of this event, 10 days. And with these pieces, we can already do some reasoning and infer the approximate end time of the event, the 16th of June. And this doesn't seem too complicated, but as you may suspect, sentences rarely come alone. So we have another example. And the next sentence also has one event, the improvement of the patient's respiratory status. And we can again observe that this event also occurred in the past. And we have some information about the event's end time, namely that it ended 2 days before antibiotics were stopped. And finally, using world knowledge about the fact that giving antibiotics is generally aimed at improving a patient's health status, we can implicitly infer that the improvement of the patient's status likely started shortly after the antibiotics were given. So this example illustrates that building a timeline of just 2 simple sentences with 2 events may already demand a temporal reasoning system to handle different elements of intervals, so start times, durations and endings, and deal with relative and absolute information, and represent vagueness or incomplete information. So for example here, the year in which all of this took place was not given at all, and should not obstruct the reasoning. So how do temporal information extraction systems typically handle this type of reasoning? So we found that most extraction systems resort to reasoning with Allen algebra, of which you can see an overview picture here. And a likely reason for this is the fact that most widely used annotation scheme for temporal information is TimeML, which connects events and temporal expressions through relations from this algebra. So in Allen algebra, there is a set of 13 temporal relations, depicted here in orange, that connect intervals and can represent all possible orderings 2 intervals may have. However, these basic relations cannot represent incomplete or uncertain information. So you need to know the order of the start and end points of both events, otherwise you cannot assign a relation. So using only basic relations limits the expressivity. So you can include partial information in Allen algebra, but this immediately brings important reasoning procedures to NP completeness, making it not so attractive in practical applications. So interestingly, we also found that some works reason via start and end points instead of interval relations, which does allow for reasoning with incomplete information without immediately going to NP completeness. So there are many subfragments of Allen algebra that facilitate this, and we believe this to be an important development in the field. And finally, while searching the literature, we found that temporal reasoning is really used and integrated across all phases of model construction, from data annotation to model development and evaluation. And with this note, I'd like to conclude this talk and refer to the longer 15-minute talk in which I will dive more into the methods used for this integration. So thank you for listening, and if you have any questions or remarks, feel free to email.